Now let's do another averages problem with z-values. This time let's go back to a two-tailed test just to show you how that would be done with z-values. It is thought that the average number of hits per day at a website is 100,000. A random sample of 40 days is selected, and it is found that the average is 94,300 and the standard deviation is 26,700 for this sample. Using a 5% level of significance, does this sample data support the idea that the average number of hits per day is 100,000? Alright, notice that this has to be a two-tailed test because it says that the average is 100,000, not whether it's more than 100,000 or less than 100,000, but is it 100,000? Okay, let's write down our sample data. Okay, so sample n is equal to 40 random days, hopefully. Average for those 40 days, 94,300, and standard deviation for those 40 days, 26,700. And the question is it equal to 100,000 hits per day? And we're going to use an alpha of 5%. Alright, so there's no question about which tail test. We can immediately go and write down our hypotheses. Null hypothesis for a two-tail test, mu is equal to a particular value, in this case 100,000. Alright, so the average is 100,000. Alternatively, mu does not equal 100,000. Alright, so the average is not 100,000. Next step is to draw our distribution. And we have a two-tail test. So we have two parts again, just like the first problems. Total alpha of 5%, so we have 2.5% in each tail. Okay, and if we go to our z-tables, the z with 2.5% in one tail is 1.96. So our critical z values will be, of course, positive 1.96, middle of 0, and the one on the lower side will be a negative 1.96. If we get between plus and minus 1.96, it's possible the average is 100,000. If we get a z-calc lower than negative 1.96 or greater than positive 1.96, it is likely the average is not 100,000. Okay, so let's write that down. Decision rule. If z-calc is between the plus and the minus 1.96, null is possible. Do not reject the null. Okay, it is possible the average number of hits per day is 100,000. Alternatively, if z-calc is not between the plus and the minus 1.96, then we will reject the null and accept the alternate and say it is likely the average number of hits per day is not 100,000. Okay. Next step is the calculations. So with an average is one sample test, we get the standard deviation S of x bar is divided by the square root of n. S is 26,700 divided by the square root of the sample size of 40. Let's go to Excel and work that out. So this is equals 26,700 divided by the square root of 40, and to 4 significant places that'll be 4,222. Alright, so 4,222. Alright, and then the z-calc, which is x bar minus mu divided by S of x bar. The x bar, the sample average is the 94,300. Mu from the null hypothesis, the 100,000 that we're testing this against, and divide that by 4,222. Okay, let's go back to Excel and work that out. So 94,300 minus 100,000 divided by standard deviation, and that's a negative 1.350. Alright, so the 94,300 is only 1.35 standard deviations below the mean or the value of 100,000, and that's well within the acceptance region, so we'll go with part 1 of the decision rule and not reject the null. So decision, since z-calc is equal to negative 1.350, and since that is between plus and minus 1.96, the critical values, do not reject the null. And the interpretation is possible. The average number of hits per day is equal to 100,000. And that's the end of our two-tail averages test using z-values.